Okay, lesson 2.2, lesson 2.2, example 1. So they're talking about applied equation problems this time. So this first one is talking about the test average. We actually went through these first two in class. So if you have already seen this, you can skip over it. If you are remote, you need to watch these. So the first one is talking about there's this student who has these first two test scores, and they want to end up with an average of an 80. So they want that third score to be high enough to get them an 80% average. So what we did was we said, well, let's let X be our third test score, because we don't know what that is. And then if I average them, so if I take the average, that means I'm going to take test 1 plus test 2 plus test 3 and divide by 3. That's how I average it. That average needs to be an 80. So I'm going to do 80 equals my first test score and my second test score, 64 and 78. I don't know that third one, and I'm just going to solve this equation. Okay, so if I solve this out, if I multiply by 3, I get 240. I'm going to go ahead and add these two together. I get 142. If I subtract 142, I end up with 98. So that means my third test score has to be a 98. Okay, so the second example, again, we talked about this one in class as well. They were talking about this clearance sale where they're saying, okay, I've got a shirt, I'm going to give you a 20% discount, and then your final shirt cost is $28. So they want to know, well, what was that pre-sale price or the original price? Okay, so I decided to call my X value my pre-sale price. And then I just made an equation that looked like this. So my pre-sale price minus my discount is going to give me my sale price. So if I had an original price, I took that discount off, that's going to give me my original, my new sale price. Okay, so my pre-sale price is what I don't know, so I'm going to call that X. Minus my discount in this case was 20%. So I need to take 20% of the original price away from that original price. So don't forget that X right there. That's where most people will mess up. And then that's going to equal my sale price, which is my new price, which in this case they told me was $28. So if I take X minus 0.2X, that gives me 0.8X, or 80% of that original price is what you're paying. And that gives me 28. So if I divide by that 0.8, that gives me 35. And in this case, we were talking price, so I'm going to put a $sign on that before I give it as my answer. So big things that my students in class have heard, but from those who are remote may not know this. We should not be using a calculator until after the midterm, according to Ivy Tech. So this calculation right here, 28 divided by 0.8, you may need to remind yourself how to divide with decimals, because on a test or a quiz, you wouldn't be able to use a calculator for that. Okay, now example 3, let me see if I can get it in view here for you. So if you're following along in your textbook, you should be able to see it. So example 3 is down here. Okay, so they're talking about an investment firm, and they have $100,000 to invest for a client. And they decide to invest it in 2 different stocks. We've got stock A and stock B. Then they tell me the annual return rate or the simple interest for each stock. So 15% for A, and then down here they told me 10% for B. But there's some risk involved with stock A. The client doesn't want to invest more than $50,000 in that one because it's risky, okay? The annual rate of return on the stable one is 10%. So stock B is 10%, but it's more stable. And they want to know, they want us to determine whether there is a way of investing the money so that the annual interest is $12,000 in one instance. So after I check that one, then I also need to check and see, is it possible that we can invest it to where there's a $13,000 annual interest? So a couple of ways that we can talk about this one. Here's how I set it up. I went through and reminded myself of this equation up here. Interest equals the principal amount times the rate times the time. Now in this case, we're talking about an annual situation. So our time would just be 1 because it's in years. So 1 year. And then the rate depends on which stock we're talking about. And then the interest also depends on how much am I putting in each one, right? But that's going to give me my interest, my simple interest. So I went through and I said, okay, I'm going to go ahead and say X. In this case, I'm going to define X as my investment in stock A. So I'm going to say that that is my stock A investment. And I'm not sure what that's going to be yet. So I don't know how much money I plan to put in stock A yet, but I'm going to call that X. The other thing that I know is that stock B, stock A and stock B together is 100,000. So I could say that 100,000 minus X, that's going to be my stock B investment. Okay. And then don't forget things like this stock A is at a 15% investment, right? 15%, yes. And stock B was at 10%. So we need to remember that. So I'm going to go ahead and write that out too. So maybe I'll write it over here. That 0.15 times my stock A investment, which I called X, that is my interest from stock A. And then my second one, that's a 10%, but it's 10% of this investment. So 0.10 of this, that is my interest from stock B. Okay, so that's a lot to kind of define there, but I feel like that was really important to get all of that defined up front. Then I can look at it and say, okay, now I'm going to talk about my interest. So part A, I'm going to go ahead and list this out as part A. They wanted to know about this $12,000, right? Well, I'm going to talk about interest for a second and what it equals. So the interest equals, that's my total interest. So I'm talking about the total amount of interest from both stock A and stock B. That's what they're wanting my interest to be. So that's what they're wanting to be, 12,000. So that would be my 0.15x plus this piece right here, my 0.10 times 100,000 minus x. Those two put together, in this case, need to be 12,000 is what they're asking me. Is this possible? So I'm going to simplify this a little bit. 0.15x plus, I'm going to go ahead and distribute this. So let's think about this. 10% of 100,000, that should be 10,000. And then minus 0.10x. Again, if you need to use a calculator on homework just to check yourself, that's fine. Just remind yourself on a test or a quiz, I don't have that advantage. So if you want to maybe, when you multiply this out, maybe do it by hand and then check yourself on the calculator to make sure you're doing it right. Gain some confidence there on your hand calculations. Okay, so then here I'm going to minus my 10,000. So that's going to give me 2,000 equals, I'm going to go ahead and put these together. 0.15 minus 0.10 would be 0.05x. And then here's another calculation I got to make. So I need to divide by 0.05. So what I did over on the side, I was like, okay, I'm going to divide 2,000 by 0.05. And in order to do that, I need to move my decimal out 2 spots. So it starts here, I need to move it out 2 spots, add some zeros in there. And then 5 into this is what I'm looking at. So 5 will go into 20 4 times, and then the rest of those will just be zeros. So you should end up with 40,000 for X. So you may need to remind yourself, like, what does that 40,000 represent? That 40,000, remember, is X. If I go back up here, if I've written this down, this is really helpful. X was how much stock A's investment was going to be. So I'm going to put 40,000 in stock A according to this. Well, that would mean I would do 60,000 in stock B, right? So this is stock B, this one is stock A. So now I got to ask myself, is this possible? Is it okay that I did 40 in A and 60 in B? And it is, because in the problem they said we can't do more than 50,000 in stock A. That was the only limit that they gave me there. So this meets those. So yes, it is possible, and that would be the investments. Now if I look at B, I can kind of take a shortcut on B. This one asked me 13,000, but it asked me to do the same thing as I did right here. So I'm just going to go ahead and start here, but put 13,000 instead of 12,000. So 13,000 equals, I'm going to go ahead and put these together. How about that? So this would be 0.05 x plus 10,000. And I probably could have just wrote 3,000 there instead. So I'm going to take that off of there. So 3,000. And if I divide by my 0.5, again, if I do this type of a calculation over here, I end up this time with 60,000 for stock A. So 60,000 equals X. Well, this does not work. Why? Because they gave me that parameter in the problem where I couldn't invest more than 50,000 in stock A because it was too risky. So A was a, yep, I can do that, it is possible. B is a no, 13,000 won't happen. Okay, example 4. This is kind of a long lesson, guys. I apologize for that. So example 4 is down here at the bottom, mixing chemicals. So in this one, I feel like these are fairly confusing, but they give you some pictures that I think help a ton. So I will kind of move over to that in a second. So this one says a chemist has 10 milliliters of a solution that contains a 30% concentrate of acid. Just that sentence alone is fairly confusing. And they want to know how many milliliters of pure acid must be added in order to increase the concentration to 50%. So we're talking mixtures here, and I'm going to move over to this picture so that you can see what we're talking about. It's a lot easier to visualize here. Okay, so here is that image that I was talking about. We've got a 30% original mixture, and they said 10 milliliters of that. Then we have this pure acid, which we're going to call X, and then we have the new mixture, which has to be a 50% mixture. So what I did, I said, I'm going to make X in this case. I'm going to have that be my, the milliliters of that pure acid that I'm supposed to have. So if we go back to the original question, it had said how many milliliters of pure acid must be added. So that's why I called that X, because that's what I don't know. That's what I'm trying to find. So I started out with, well, they gave me that I had 30%, and I may have to go back to the original problem. I had 10 milliliters. Let's go back here again. It's gonna be really hard to see. I keep switching back and forth. Okay, so the original problem, I had 10 milliliters right here, and it was a 30% concentration. So that's where I said, okay, well, I've got 10 milliliters with a 30% concentration. So that's why I did that piece. then plus I'm going to add pure acid to it. Well, if it's pure acid, that's 100%. So 1.00 of that pure acid, however many milliliters of that you're going to put in there. And by mixing those two things, I should get the final result, which was a 50% mixture, 50% concentration of, this is a mixture of the two of them put together, right? So that's my 10 milliliters plus whatever else I put in right here. So I've got my 10 plus my X. Okay, hopefully this image though in your book, I really think that this this setup is really easy to see. So when you get to these mixture problems, you may want to go back to this example and look at these pictures in the book. It really helps. Okay, so I'm going to just work all this out. So 30% of 10, that's 3, plus 100% of X, I'm just going to call that X. And then this 50% of 10 is 5, plus 50% of X, I'm just going to have to write that as 0.5X. I can take the 0 off the end though. And then I'm just going to start putting things together. So I'm going to subtract my 3 right here and make that a 2. And I'm going to subtract my 0.5x over here and make that 0.5x. So I just did 2 steps in one. Then I'm going to divide by 0.5. Well, dividing by 0.5 gives me 4. So I want you to think about it like this. If I had half of what, I would get 2. And that would be half of 4 gives me 2. So that's 4 milliliters is what the question was. So what does that tell me again? So X was the amount of pure acid, right? So this is 4 milliliters of pure acid would have to be added to that mixture to make that happen. Okay, example 5, keep moving here. So example 5 is another mixture problem. So actually, I'm going to skip this one because it is a very similar situation. So right here is the picture that goes with it. I do think the book does a pretty good job of telling you how to do these problems. So if you need another example of a mixture problem, example 5 is a good one for you to look at. So just go back and take a look at that one. But it's the same idea. And then example 6, this one is pretty important. So we encounter these types of problems a lot in algebra. This is where you've got one car leaving the city and then you've got another car leaving the city after them, but they're traveling faster. When are they going to meet up, right? So I always make a table like the book does right here. I label mine a little bit differently because I think of it as distance equals rate times time. So when I'm doing these types of problems, I think of that, D equals RT. So when I made my table, I said, okay, this is the car that I'm talking about, car 1 or car 2. And then I've got some kind of a rate, like how fast are they going down the road? How long are they doing that for? That's the time that has went by. And then that's going to give me their distance overall. So this is how I always set up these types of problems. And then I go back to the problem and I get this information out of it. So they told me in this one that car A leaves city B at 1 o'clock. They're traveling a constant rate of 40 miles per hour. So they're going 40 miles per hour. That is their rate. So I'm going to go ahead and put that in there. Time, they told me they left at 1 o'clock, but they didn't tell me anything else after that that helps me know how long they did that for. So my time, I'm just going to call T for that one because I'm not sure. My distance, remember this formula right here. Distance equals rate times time. So I don't know what the distance is yet, but I know that that equals 40 times T. So I'm just going to call this 40T. And then car 2. So in this one, they said another car leaves, let's see, B and travels towards C at a constant rate of 55 miles per hour. So right there, they told me that the rate was 55. Now, the time, what they told me here is that 30 minutes later is when that car left. So I'm not sure how long they traveled for, but I do know that it's 30 minutes less than what the other car traveled. So if I'm calling that car's time T, then this one is going to be T minus half an hour. Remember, time is in hours. So if they said 30 minutes, I'm going to call that half of an hour, or I could have said 0.5. So my distance in this case is 55 times T minus 1/2, which I can simplify later. Okay, now the big setup on this is they want to know at what time will the second car reach the first car? So when will their distances be the same? That is the question. When will they be the same? So when will 40T be the same as 55 T minus 1/2? Oh, 1/2, that's what that is. Okay. So then I'm going to just solve this out. So 40T equals 55T minus half of 55. So I'm going to call that 27.5, or 20, you could have said 27.5, and that's fine. So then that gives me, let's see, I'm going to subtract away my 55T. So that gives me negative 15T equals negative 27. I'm going to change that to 0.5, and I'll show you why. If I can't use a calculator, this is the easiest way for me to do it by hand. So I'm going to divide by negative 15. So my negatives are going to cancel. That's good. But I'm going to write this as, I'm going to move my decimal over. But if I do it there, I have to do it down here also. So that's going to give me 275 over 150. And then I'm going to simplify that. And this is just a personal preference. You don't have to do it that way. If you're like, no, I want to take 27.5 and divide it by 15 by hand, that's fine. I'm just going to do mine as a fraction. So let's see, I can simplify those both by 5. If I divide by 5, 5 will go into 27 5 times with 2 left over. So bring down my 5, that'd be 25. So it'd be 55. Again, that was in my head. You can do that by hand, it's fine. And then 150 divided by 5, 15 divided by 5 is 3. And then the 0, so 30. And then these are both divisible by 5 again. So let me just do that again. That means that these, obviously, they were both divisible by 25. I could have just counted by 25s. That may have been easier. Oh, well. Divide by 5, that gives me 11 over 6. So, okay, so then let's think about this in hours and minutes. So this is the same thing as 1 and 5/6. Well, this is time, so I really need to think about it as hours and minutes. So this is 1 hour, and then 5/6 of an hour. Well, if you think about in 60 minutes, this is 50 out of 60. So this is an hour and 50 minutes. So 1 hour, 50 minutes. And then I'm curious, let's go back to the question. Yeah, so it says, at what time will the second car reach the first car? So remember back when they told me 1 o'clock was when the first car left? That's important now, because an hour and 50 minutes after they left, that first car left, that's when they will meet. So if they started at 1 o'clock, then really at 2:50 p.m., that's when they will meet. So an hour and 50 minutes after the first car left, which makes it 2:50 p.m. Okay, so I will put the assignment, I'll put this video in with the assignment, and I'll list out the numbers that I'm asking you to do, and Monday will be some work time for you. Thanks.